Welcome to our presentation. This was our group is Team 2, and we were in charge of Chapter 4, the Internet of Things. Here's a brief overview of our presentation. The different parts of the presentation will go over the history, the components, their current applications, the future of Internet of Things, and then the potential issues.
A quick history on the Internet of Things. What is Internet of Things, or IoT? Internet of Things is a set of capabilities enabled when physical devices are connected to the Internet via sensors. These devices have the ability to communicate without human interaction at all. The most well-known is the Amazon Alexa device, which is an audio sensor that detects voice commands. The Alexa sends audio data to another device, which will send back a response or perform an action based on the original audio input. Other examples of IoT include machine-to-machine devices that communicate using Wi-Fi or other network infrastructures. The phrase IoT started in 1999. Kevin Ashton, a cosmetics brand manager for Procter & Gamble, tried to figure out why one shade of lipstick was always sold out at his local store. This led Ashton to wonder if RFID chips could be used to track lipstick on store shelves. Ashton gave a presentation and convinced P&G executives to fund an MIT project that used RFID tags and other sensors in the supply chain to track products. In his presentation, he described the supply chain being a network of things and how the internet was a network of bits. He then combined the two ideas, plus all of the other sensor integration, into the phrase, the Internet of Things. While the phrase didn't catch on immediately, it did eventually take on a life of its own when Ashton and the MIT research team started the Auto ID Center. 8 years later, IoT's popularity increased dramatically when people began using the IoT hashtag on the social networking site Twitter. Since the foundation of the Auto ID Center, the use of IoT has grown beyond a few MIT scientists using it to the more mainstream use that we see in home and businesses today.
There are several components to the IoT architecture. The base component level of IoT is comprised of the wide range of endpoint devices that enable the gathering and transmission of data. Apparatuses such as mobile phones, pressure sensors, and digitalized security systems are all prime examples of the intelligent edge nodes that fall under the category of things. The next level of IoT architecture is connectivity. The primary focus of this level is to establish reliable and timely data transmissions between devices and networks. This occurs when endpoint devices are integrated with connectivity equipment to facilitate low-level information processing, also known as fog computing. After that is the component of global infrastructure, which encompasses all the tools and applications that allow a user to collect, process, manage, and store massive amounts of data in real time. We then have the components of data accumulation and analysis. This deals with the aggregation of data to enable the development of simpler, performance-based apps and convert analog data into query-based processing. We then move on to the level of applications. These are programs which bridge the gap between the physical and digital world to improve quality of life, society, and industries. Lastly is the level of people and processes. This encompasses the collaboration of IoT components for the enhancement of all business processes and decisions.
The top 3 applications of the Internet of Things are smart appliances, smart energy meters, and wearable devices. The companies that are the most popular Internet of Things providers are companies that provide the actual engineering, software, and technology that makes it possible for the Internet of Things to function. Current applications of the Internet of Things include the Skybell home doorbell that instantly alerts you of who is ringing your doorbell so that you can see, hear, and talk to the person ringing your Skybell live via an app on your wireless phone anywhere you are located in the world. Another application of the Internet of Things is through wearable devices that integrate healthcare, such as the Guardian Glucose Monitor, a device that helps people with diabetes by detecting glucose levels in the body. A glucose sensor is placed on the skin, and the sensor relays the user's glucose level through radio frequency signals to a monitoring device. Connected cars are another example of how the Internet of Things work. For example, when a hurricane was approaching Florida and people were scrambling to line up at gas stations to fill up their cars with gas to evacuate, Tesla's CEO announced that the electric automaker would boost the range of their Model 3 cars. Tesla remotely charged the batteries of their Model 3 cars to help Tesla car owners drive further and get out of the hurricane's path.
Regarding the Internet of Things, everything that can be connected will be connected, if you want it that way, and sometimes even if you don't. Massive amounts of data will be collected by these devices, but the information we receive will be synthesized into usable chunks. The Internet of Things will connect everything from devices to large infrastructures. We will have smart shopping carts and smart cities. Industry 4.0 will revolutionize manufacturing through the implementation of the Internet of Things, creating smart factories where a virtual replication of the physical world is created and decentralized decisions are made. Pictured is a workbench that is currently made by Autodesk, but is an example of the standard small workspace of the future, enabling craftsmen to inexpensively use the Internet of Things. It has an acrylic covered display and a camera that tracks the placement of the work and can measure in a variety of ways. It includes tool safety and tutorials. It connects to other smart tools in the workspace for ease of finding the right tool at the right time. Currently, agriculture incorporates data, but it's often too much raw data to be useful to the industry. Smart agriculture synthesizes data into usable, informed suggestions. The output of agriculture, food, can then be RFID enabled to improve shelf life by using a first expired, first out method of logistics rather than first in, first out. The precision the data can give to food production can reduce waste and insurance costs. So the future is fascinating as we increasingly incorporate the Internet of Things.
And now finally to the potential issues of Internet of Things to wrap up the presentation. The three major potential issues that Internet of Things presents is the security, the connectivity, and the privacy. Given the current trends, the impact of Internet of Things on human life is increasing exponentially and will only continue to rise. Questions have emerged at the same time about the potential risks that IoT presents. Cybercrime and the security of the cloud are major issues of the IoT system, and all cyber attacks cause around $1 trillion in damages per year. Another issue arises in the connectivity of the IoT system. The pool of data depends solely on the bandwidth of the internet in your immediate area. Without a solid connection, the system fails, rendering the Internet of Things useless. And the final component, or the final potential issue, is privacy. It's another major concern that your data that your devices are recording and sending to the cloud can possibly be leaked. Thank you for listening to our presentation, and we'd like to invite any questions about the presentation or the Internet of Things as a whole.